Greetings everyone, and welcome to my Python course. In this video, we are going to talk about data types in Python. Data types are crucial in Python programming, defining values and determining code efficiency. Python's dynamic type nature ensures accurate and efficient code manipulation. Python's data types categorize and manage data, enabling diverse operations. Built-in types like integers, floats, strings, lists, tuples, dictionaries, and sets form the program's core. Now let's get started. The first data type that we will talk about is the numeric data types, which are integers and floats. Numbers are the heart of many programs. In this part, we will explore the two types of numbers. Integers, which are whole numbers, like counting apples and oranges. For example, 1, 2, 3, and 4. These are integers. On the other hand, floats, which include decimal points for more precise calculations, such as 1.2, 2.5, and 3.7, etc. Let's talk about the type function in Python in order to understand. The type function is like a detective that helps us uncover the true nature of something. It's used to find out the data type of a value or variable. In other words, it tells us what kind of thing we are dealing with. Imagine you are holding an object in your hand, but you are not sure what it is. Is it a number, a word, or a list of items? That's where the type function comes to the rescue. Let's perform an example to understand. Let's make a variable called value and assign its value to 42. We execute the code with Shift-Enter, and then let's make another variable called data type. Data type equal to type function, and then we enter the value that we assigned its value to 42. And now let's print the data type in order to check the type of this value. Print data type. Shift-Enter, and here we have it. The type of the data type is integer. In this example, we have assigned the value 42 to a variable called value. Then we use the type function to figure out what kind of data value represents. When we print the result, we will see that it's an int or integers. This tells us that value is a whole number. In Python, we can do many arithmetic operations. For example, let's create two variables, x and y. Example, x equals 7. Then we press enter to go to next line, and y equal to 2. Now let's create a variable called s, and then we assign the value of it, x plus y. Now let's print s. We got 9, because when we created the variable s, we assign its value to x plus y, which is 7 plus 2, which gives 9. This variable s can be made with any name, for example, potato, elephant, or monkey. For example, monkey equal x plus y, and then print monkey gives us 9. We can also make another variable and call it sub equal to x minus y, print sub gives us 5, because we assigned the value x minus y, which is 7 minus 2. Can also make division x over y, and then print div 3.5. In addition to multiplication, x times y In Python, the star sign is to multiply two items together. For example, x and then star y, which is x multiplied by y, and then print multiplication, and it gives us 13. And as we agreed before, we can give any name we want. Multiplication, potatoes, unicorn, anything. In Python, data types can be categorized as either mutable or immutable. The distinction between mutable and immutable data types lies in whether the value of an object can be changed after it's created. The mutable data types are lists, dictionaries, sets, whereas the immutable data types are integers, floats, strings, and tuples, starting by integers and floats, where they are immutable data types. Now let's implement an example to check the mutability or immutability of the integers. Example, x equal 10 and y equal x. And here we can write a comment as we agreed before, shift and hashtag, as we did before in the last episode. We write a comment, assign the value of x to y. Now let's print the original x. In order to print any text, we have to put the text between quotes, either single quotes or double quotes. So for example, original x, and then we have to write a comma and then the variable, which is x, that we want to print. We want to print also original y, and then comma and then y. Now let's perform the print function. Now let's try to modify the x. For example, x equal to 20, and then print modify x and then x, and then print y. As we can see, x now equal to 20, but y is still 10. In this example, when we modify the value of x, it doesn't affect the value of y. This demonstrates the integers are immutable. When you change the value of an integer value, a new integer object is created in memory, and the variable is updated to point to the new object. Imagine you have two boxes, one labeled x and another labeled y. Inside the x label, you put number 5, and inside y box, you put the number 5 as well. Now these boxes are like our variables. When we change what's inside the x box to 10, the y box remains with the number 5. This is because the number inside each box cannot be changed directly. So in Python, we have numbers like 5 and 10. When we put these numbers in our x and y boxes, they are like variables. But here's the interesting part. If we change the number in the x box to 10, the y box still has the old number 5. That's because these numbers are like special boxes that cannot be changed once they are inside. Now let's check the float numbers. Let's create a variable called a equal to 3.14. Now let's check the data type of variable a. And here we have it. The type of the variable a is float. But what if we assign a new variable called b and make it equal to a? b equal a, and then we'll print original a and print original b. We got it. The original a is 3.14 and the original b is 3.14 too. Now let's try to modify A. For example, A equal 2.71. Let's print the modified A and print unchanged B. We got modified A is 2.71, but the B is unchanged, which is 3.14. At the start, we established a variable A with a 3.14 value. Additionally, we created another variable B and assigned it the same value as A. Think of these variables, as we said before, as containers or boxes. A and B holds the same floating point number, which is 3.14. But when we print out the values of A and B, both display the original value of 3.14. Now comes the intriguing part. We decide to update the value of A by setting it to 2.71. This action is like pointing out the contents of the A container and filling it with a different number. What's noteworthy is that while A has changed to 2.71, the B container remains unchanged, still carrying the original value of 3.14. This demonstrates that altering or changing the value of A didn't cause any changes in B. This behavior underscores the concept of immutability. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel, hit the like button, share the video, and leave your comment under the comment section. Until next time, happy analyzing.